pick up with. So we've talked about solving these equations. Today we want to look at a special application that we're going to write equations for, and that is solution mixing. Every solution has two parts. It has a solvent and it has a solute. The solvent is kind of the carrier. In medical terms, we refer to it as a vehicle. It is basically a non-active, a neutral substance. By neutral, I mean it really has no medical value. That carries the solute. If we were looking at a common solution, would be salt water. Water would be the solvent. It is carrying the salt. The salt would be the solute. The solute is generally what we call the active ingredient. In terms, it would be the medication. Most of the times, by the way, our solvent, medical applications, is either going to be water or saline. We're going to use the abbreviation NS. NS can stand for a number of things. It can stand for neutral solution. Or normal saline. Normal saline, neutral solution, both of them, I mean, there are other things other than normal saline that can be a neutral solution. But normal saline is the most common one, and really all it is it's water that is sterilized and pH balanced to match the pH of a human body. So when we're looking at these solutions, we want to know how much of the active ingredient we have. And the amount of the active ingredient, the amount of the solute, is equal to our concentration times the total amount of solution. So what does this mean? Well, for an example here, let's say we ask how much salt is in 400 milligrams of 12% solution. Obviously, some sort of saltwater solution. So the amount of salt is going to be the concentration. Well, that is our percent written as a rate or as a decimal. So 12% is 0.12 times the total amount of solution. Well, we have 400 milligrams. And of course, if we do that multiplication, 0.12 times 400 is going to give us 48 milligrams of salt. So pretty simple calculation. Well, what we're concerned with is mixing solutions. I'm going to mix solutions. There's two things that have to stay constant. First thing that stays constant is the total amount of solution. If I add 200 milligrams of solution to a solution that's already 400 milligrams, that adds up to 600 milligrams. That is constant. That is conserved. other thing that is conserved or held constant, the amount of solute. So if there's 48 grams of salt in one solution and 20 grams of salt in the other solution, if we mix them together, there's going to be a total of 68 milligrams of salt. Well, let's see how this relates. Let's find the concentration if 170 milligrams of 24% solution mixed with 510 milligrams of 32% solution. So again, there's two things that need to be conserved. I'm going to have solution A, which is going to be the things I'm going to mix here are going to be solutions A and B. I have a 24% solution and a 32% solution. I want to find whatever that new percent is. But I have 170 milligrams of the 24% solution and 510 milligrams of the 32% solution. The total amount is conserved. So if I add those together, 170 plus 510, there's 680 milligrams of that final solution. That is my first conservation, the total amount. Second thing that has to remain constant or be conserved, as we say, is the amount of the solute. Well, remember, the amount of solute is the concentration times the total amount. So the solute from the first one here, the 24%, 0.24, that's 24% is a rate, times the amount of 170 milligrams. I add that then to the second solute, which was the 32%. So as a concentration, that's 0.32 times the amount there of 510 milligrams. Equals, that has to add up to the total amount of solute. Well, I don't know the concentration, that's my X. That'll be multiplied by 680 milligrams. And now I can go through and solve this to figure out how much of each, what is that final concentration. So here, 0.24 times 170. .8 milligrams of solute in that first solution. 0.32 times 510. 163.2 milligrams in that second solution. On the right side, X times 680, I'm just going to write that as 680X because that's the way we're used to seeing that. Back on the left side here, we need to add these. 40.8 plus 163.2, 104, X. And now we'll solve by dividing by 680. Divided by 680.3. So once we've solved for X, in any sort of word problem, any sort of problem really where we're solving an equation, we need to do two things once we've solved for X. One is we need to make sure we remember what X represents. Well, here, X represented the concentration, the final concentration. That's 0.3. Next thing we need to do, the second thing we need to do, is to make sure we have answered the question. The question is saying find the concentration. Well, 0.3 is the concentration, but we typically want that as a percent. That solution would be a 30% solution. Now, most of the time, we are not randomly mixing two solutions and then trying to figure out what we got in the end. Most of the time, what we're doing is we are trying to create a desired concentration in our solution. So we will be doing something like this. How much? 71% solution. Should be mixed with 120 milligrams of percent solution. A 5% solution. So when we look at this, we need to identify what it is we are mixing. We are mixing a 71% solution with 62%. Mixed. We're trying to get, we want a 65% solution. That's what we desire. That's what we want. You know 120 milligrams is the amount of solution. Rest, how much of the 71% solution? So what we're trying to find is the amount of the 71% solution. Now, just like this last problem, the total amount is conserved. It adds up to a constant. Here we had the two numbers and we added them together to get the total. Down here, one of those values is missing, but we can still add them up to get a total. Total amount of solution, the 65% solution we're going to have, will be x plus 120. And then, of course, we have to find our amount of solute, or find the equation for the total amount of solute. Well, this is 0.71 times x plus, this one will be 0.62 times 120 equals, this one is going to be a concentration of 0.65 times the amount there will be x plus 120. And once again, we have an equation we can solve. As always, we'll start by combining what we can on either side. On the left side, well, the 0.71x isn't going to change, but we do have 0.62 times 120. 74.4. On the right side, we have the parentheses. There's nothing to do inside the parentheses. So we'll go ahead and multiply by the 0.65. 0.65 times x is 0.65x. 0.65 times 120, I believe that is 78. Double check that. It is 78. So we've combined everything we can combine on each side. Next, we need to make sure the variable is on one side. Here, of course, the variable's on both sides, so we're going to have to get rid of one of them. Smaller one is the 0.65x. Positive, so we're going to get rid of it by subtracting it. So on the left side, 0.71x minus 0.65x is 0.06x. Plus the 74.4 is still there. On the right side, x is gone, and all we have left is 78. Now we're ready to solve. So we will subtract the 74.4. 0.06x equals 3.6. And finally, we divide 0.06. X equals Now again, we need to make sure we know what that represents. X was the amount of the 71% solution. Our other amounts were in milligrams, so that is in milligrams as well. Make sure we've answered the question. We're asked how much of the 71% solution, and yes, that is our answer. 60 milligrams is how much we need. Don't always know the amount of one of the solutions. In fact, it's kind of inefficient. Here where we knew that we had 120 milligrams of the 62% solution, because it gives us an undeterminate amount of our final solution. So in many cases, we want to know how much of each of these ingredients to get a specific amount of that final solution. So we might ask, how much 28% solution and 16%. Could be mixed. Create 360 milligrams of, what do I want to put? 25% solution. So again, we look at what it is we're going to be mixing. We're going to mix 28% and 16%. Hoping to create what we want, 25% solution. Looking at the amounts, the only amount we know is the 360 milligrams, and that is our desired amount of the 25% solution. Now looking at this, there are two amounts we're trying to find. We want to know the amount of the 28 and the amount of the 16. We're tempted to define two variables, maybe x and y or other two letters, but we don't know, at this point, we don't know how to solve any equation with two variables in it. We need a system of equations. But we can express this as just a single equation. If I let the amount of 28% be x milligrams, the amount of 16% solution is just whatever's left over. Our total of 360 minus the x that we already used for the 28%. Notice if we add that up, x plus 360 minus x, that does add up to 360. Now we can use those to create our equation. So for the 28%, concentration of 0.28 times x. For the 16%, concentration of 0.16 times 160 minus x. Add those two together to get our total of 360 milligrams. Now it's a matter of solving the equation. So we start on the left, combining what we can combine. Well, the 0.28x is just going to be 0.28x. Parentheses, there's nothing to do inside the parentheses, so we'll distribute this the 0.16. 0.16 times 360. 7.6 is a positive 57.6. And 0.16 times a negative x is a negative 0.16x. Now there's still more we can combine on this left side, so let's keep doing that. We've got the 0.28x and a negative 0.16x gives me a 0.12x. We still have the 57.6, so positive 57.6. And there we have combined everything we can on the left side. On the right side, well, just the 360, there's nothing to combine there. Nothing changes. Combined everything we can combine. The variable is on one side, so we are now ready to solve. Go ahead and subtract 57.6. 0.12x equals 0.4. Then we'll divide by the 0.12. X equals 302.4 divided by 0.12. $1,520. So looking at what happened here, 2,520 is the amount X, that is in milligrams. Something's off there, because we have a total of 360. So let's go back and see what went wrong here. I see what I went wrong. Right in that first equation. This should have been the concentration of 0.25 times the 360, which should have given us only 90 milligrams as we went down through here. So a quick adjustment here, 90 milligrams minus the 57.6 would have been 32.4. And 32.4 divided by the 0.12, 270. That's more reasonable. Smaller than our total of 360, so that's doable. So we have 270 milligrams for the 28%. But again, we have to make sure we answer the question. We need the 16% as well, so 360 minus 270 is 90 milligrams of the 16%. I made a mistake on this one. Let's do one more example similar to that. You can see there's a lot of steps here, so there's a lot of chances to make a mistake on. Let's ask how much 7% and let's put up 22%. Solution should be mixed. Create 120 milligrams of 12% solution. So again, we look at what we're mixing here. 7% and 22%. Get what we want. That is the 12% solution. Our amounts, well, again, we only know that we're going to end up with 120 milligrams of the 12%. So once again, I'll come back here. Now, I typically let X be the larger percent, but it doesn't matter. I can let the first one be X. This amount then would be the total of 120 minus X. So those have to add up to the 120. Now we can write our equation for our solute. Concentration, 7% is 0.07 times X. Plus here, concentration of 22% is 0.22 times the amount of 120 minus X equals, over here we have a concentration of 12, so 0.12 times 120. So let's combine. On the left side, the 0.07x hasn't changed yet, but we do have to distribute the 0.22 through the parentheses. 0.22 times 120. I believe that's 26.4. Double check it. It is. And 0.22 times the negative x is a negative 0.22x. Now there's more we can combine here. We have the 0.7x and the negative 0.22x. That is a negative 0.15x. We'll have the plus 26.4. On the right side, we have 0.12 times 120. That is 14.4. Now we're ready to go through the process of solving. So we'll subtract the 26.4. Negative 0.15x equals, this ends up being a negative 12. Now we divide by negative 0.15. On the left side, the negative 0.15's cancel out, leave us with x. On the right side, negative 12 divided by negative 0.15 is 80. So again, we've solved the equation. We need to go back, make sure we know what the variable tells us, and that we have answered the question. X equals 80 is telling us that it's 80 milligrams of the 7% solution. We still need the 120, the 22%. So it's 120 minus 80, 40 milligrams of the 22% solution. Another type of problem we could run into is we could have an IV bag (140 milliliters) of, oh, let's see what I want. 24% solution. Well, it's a little less. So 36%. Now, an IV bag is a prepackaged solution for hooking up to an IV for putting medication into a patient. How much should be removed and replaced NS, that normal saline or neutral solution, to get to, well, let's say we want this to be 30% solution. So the bag comes prepackaged at 36%. We want to remove part of that solution and just add a normal saline neutral solution to dilute it down. And we can't just add the saline because the bag only has so much that it can hold. It can only hold 240 milliliters. So here we need to look at what it is we're mixing. Well, we have the 36%. And what we're mixing with that is 0%. Remember, normal saline or neutral solution is inactive. It's 0%. We want to get to a 30% solution. How much do we have? Well, we know that the bag holds 240 milliliters. So we know that when we're done, there will be 240 milliliters in the bag. So that's going to be, even though that is the 36% right now, that's not how much we're going to have in the end. That's how much of the 30% solution we're going to have in the end. We're going to remove a certain amount. That's going to be my X. The amount we remove and the amount we replace will be the same. So X is the amount of normal saline added. That's also going to be the amount that we remove. So then the 36%, the amount of 36% is the amount that it gets left in the bag. That's the original 240 milliliters minus the X milliliters that we removed. Of course, that adds up to 240. Now we'll go ahead and write our equation. 36% is 0.36 times that amount of 240 minus X. We're going to add to that. For our normal saline, we have 0% times X. Well, 0x we know is just 0, so we're going to just cross that off. Equals, for the final amount, we have 30% times 240 milliliters. Now we'll go ahead and combine. Distributing through the first parentheses, 0.36 times 240. It's 86.4. 0.36 times a negative x is a negative 0.36x. Like I said, the 0x is just 0, so that is gone. So we're done combining on the left side. On the right side, we have 0.3 times 24, which is 72. Find everything we can combine. The variable is on one side. We are ready to solve. Subtract 86.4. Here's with a negative 0.36x equals negative 13.4. We finish by dividing by the negative x. X equals 40. Now again, we need to make sure we've answered the question. X equals 40. That is the amount of normal saline added. That's also the amount of 36% that will be removed. That is exactly what we asked. It should be removed and replaced. So we would remove 40 milliliters from that bag and replace that with normal saline or neutral solution. Now these type of mixture problems apply to a lot of other different problems out there. All sorts of chemistry applications like we're doing here. But there's also business applications, investment. Well, let's say that we invest a total of $5,000 in a mixture of 6% and 4% counts. At the end of the first year, total $230 in interest is earned. How much was invested in each account? Now here, we're all talking about solutions, obviously, so we don't have total solution and solute. What we have here is the interest rate investment. But it's the exact same form of a formula. Same formula, just different items in that formula. So once again, we'll look at what it is we are mixing. We're mixing different accounts in this case. But we have a 6% and a 4% account. And our final amount, $230. Now we don't know how much was invested in each account, but we do know it was a total of $5,000 invested. So if I let X be the amount invested in the 6%, 5,000 minus X would again be the amount invested in the 4%. Add up. So then we write our equation again. 6% investment, 0.06, the amount is X. So 0.06 times X for the 4% investment. 4% is 0.04 times that amount of 5,000 minus X. Equals, well, over here we don't know the rate, but we do know the total interest is 230. We don't have to do anything to that. That is already a percentage of the total amount. So next, we combine what we can combine. 0.06x, nothing to do there. Distribute the 0.04. 0.04 times 5,000. 100, I believe. 0.04 times negative x is a negative 0.04x. 230. Still combining on the left side. 0.06x and a negative 0.04x is 0.02x. 130. Now we're ready to solve. Go ahead and subtract 200. 0.02x equals 30. And we will divide by 0.02. X equals 1,500. Now again, we need to go back, make sure we know what X represents, and make sure we've answered the question. X represented the amount of the 6%. So there's 1,500 put in the 6%. But we also need to know how much was in the 4%. That'll be 5,000 minus 1,500, or 3,500. So our result, we had invested $1,500 at 6%, $3,500 in the 4%. Back to the medical side of things. Again, we have an IV bag. Contains 720 milliliters of solution. How much should be removed? And replaced with heparin to increase the concentration to 52%. So we currently have this IV bag that's a full bag, 720 milliliters at 36%. We want to increase its solution, its concentration to 52%. So what we are mixing here, the 36%, and then the heparin is a purification. That is 100% solution, not diluted at all. And we want to get a 52% solution. The only amount we know is that we have 720 milliliters in the bag. We'll have that much in there when we have the desired amount. 100% is going to be the amount removed and replaced. We'll put X there. The amount of the 36% solution that remains in the bag will be the full amount, 720 milliliters, minus however much we had to remove, so minus X. So again, those have to add up to conserve the total volumes. Now we can write our equations. 0.36 for 36% times 720 minus X plus 100% is going to be just 1.00 or just 1 times X equals 0.52 times 720. So we'll go ahead and combine these. 0.36 times 720. $59.2. 0.36 times negative X is a negative 0.36X. Plus 1X. Well, we have more that we can combine there. Let's combine the negative 0.36X with the positive 1X. That is a 0.64X. We'll have the positive 259.2. On the right side, it's just 0.52 times 720. Gives 374.4. Now we're ready to solve. Back to 259.2. Odds of 0.64x equals, where's work the calculator? 115.2, and we divide by the 0.64. X equals 115.2 divided by 0.64. 180. Again, we have to go back, make sure we know what X represents, and make sure we've answered the question. 180 milliliters is the amount that we would remove and replace with pure heparin. That is what we're being asked for, so there's our solution. Our homework. Page 1 through 15. I would suggest you do a majority of these problems. These mixture problems tend to give students a little bit of difficulty. Now remember, this Friday, we're not having class. We have 2 schools that are out on break for in-services. I also have appointments to go to, so I will not see you all again until Monday. You guys have a great weekend.